So, question 11a. This is a problem-solving question, and it does actually require some knowledge from Unit 3 that we've not learned about yet. I'll point that out when we go through it. Some of you may have been able to figure it out. Okay? In this question, you're asked to calculate the mass of ethanol in grams in 1,000 centimeters cubed of breath when voltage is 21 millivolts. Okay? So, I've copied out the graph from the question up here. It's obviously in more detail in the questions because there's minor grid lines, but I'll show you how to work out first of all the volume of the ethanol when the voltage is 21 millivolts. So the first thing you need to do is you need to look at the graph and you need to read up the y-axis until you get to 21 millivolts. Then you read across, try and draw a straight line, and you look at where that line intersects the line, and then you read down to the x-axis to find the volume in centimeters cubed per 1,000 centimeters cubed. Okay, and that is actually 110 centimeters cubed. Okay, so that's your first mark there, figuring out the volume. That volume is also equal to 0.11 litres. Okay, the next section is we need to convert this volume into the number of moles. Okay, and to do that we're going to use, this is the Unit 3 part, we're going to use a formula that you may not already know, but it's the number of moles is equal to the volume over the molar volume. Okay, so we're trying to work out the number of moles. We know that the volume is 0.11 litres. Okay, the molar volume from the question is 24.0 litres. Okay, so we put this information into the equation, 0.11 divided by 24.0, and we'll just work that out. I'll just work that out in my calculator. 0.11 divided by 24 equals 0.00458 moles. Okay, so the next part is we need to work out the number of grams of ethanol in 1,000 centimeters cubed. So we need to convert this number here to a mass. Okay, so this is the third mark for the question. We need to use a formula that you already know. We need to use N equals M over GFM. Okay, we need to rearrange that so that we've got M equals N times GFM. Okay, so M is what we're looking for. N is equal to 0.00458 moles, and the GFM we can work out from ethanol's molecular formula. Okay, so I've drawn it out over here. You should know how to do this. There's one oxygen, so that's 1 times 16, which is obviously equal to 16. There's 6 hydrogens, multiply that by 1, the mass of hydrogen. Okay, and there are 2 carbons, so that's 2 times 12, which equals 24. We add all that up together and we get 46 grams. So the gram formula mass of ethanol is 46 grams. So we'll put that down here to what we know. Okay, then we add this to our equation. So it's 0.00458 times 46 will give us the mass of ethanol in 1,000 centimeters cubed of breath. Okay, so 0.00458 times 46 is equal to 0.21 grams. Alright, so just the breakdown of the marks here, you get 1 mark for telling me the volume in litres, 1 mark for telling me the number of moles of ethanol that we have, and the final mark is for telling me the mass of the ethanol that we have. Okay, question 11, part B. So in this question we've been given the ion-electron equations for the oxidation and the reduction of the reaction taking place in this question. Okay, So what we need to do here is we need to identify the oxidation and reduction reactions, which one's which, then we need to write out the overall redox equation. And in this example, we've got hydrogen ions and electrons and also water appearing on both sides of the reaction arrow. So when we add these together, we're going to get quite a lot of things cancelling out. Okay? So first of all, we'll identify the reduction and the oxidation reactions. So this top one here, because we are adding hydrogen ions and electrons, that fits in with our definition of what a redox reaction, a reduction reaction is. Okay? And in here, the ethanol is losing hydrogen and losing electrons. So that fits in with an oxidation. Okay? Now, to write out the redox equation, what I need to do is I need to add these two ion-electron equations together. Okay? Now, because the hydrogens, there's 4 of each on each side of the arrow, they cancel out. And there's 4 of the electrons on each side of the arrow. Water also appears on both sides of the arrow. Okay? But there's 2 up here and there's only 1 here. Okay? So this one is going to cancel and I'm only going to have 1 water left over in the overall redox equation. Okay, so I'll write the redox equation out. I've got CH3CH2OH plus oxygen from the top line. And then I've got CH3COOH plus 1 H2O here. Okay, so that's the overall redox reaction for question 11, part B. Question 13a. In this question, you are asked to write the ion-electron equation for the reduction reaction from the redox equation. Okay, so the first thing you need to do is you need to identify what species is being reduced. Okay, so if we look up here, we can see that the manganate is reacting to form manganese. Okay, oxygen is being lost, so we have a reduction reaction happening here. So we can bring this down here, manganate forming manganese. Okay, you can actually look up the data book and find out the reduction reaction for manganate, or you can just work it out yourself following the rules that we know. Okay, so you can see that the oxygens are not balanced, so we need to balance them off first by adding water. Okay, there's 4 oxygens over here, so I'll need to add 4 in front of the H2O. And I have 8 hydrogens over here, so I need to balance that off by adding 8 hydrogen ions over here. And the final thing that I need to balance is the charge. So I've got 8 and a negative charge here, so the overall charge over here is 7 positive, and the overall charge over here is 2 positive. So to have the same charge on each side, I need to add 5 electrons here. Okay, so there's the ion-electron equation for the reduction reaction. Okay, question 13, part B. Now this question would be quite difficult for you guys to answer because you've not actually performed this experiment. We'd usually do this reaction in class, so you would know the answer to 13b. So the question is, why was no indicator required in this titration? And the answer is because there is a colour change from when manganate reacts to form the manganate ions. Okay, so this reaction is self-indicating. Okay, so that's the answer to part B. This reaction is self-indicating. Okay, so like I said, we would have normally carried this experiment out in class, so you would normally know that this reaction is self-indicating.